morning, friends. Am I audible? Is the screen visible? Okay, thank you. So we are trying to make our machine understand what we are thinking, how we are thinking. That means how we build our knowledge and how the knowledge bank is created, and later how this knowledge bank is useful for making our decisions or understanding the world and live. So we want our machine to do same thing. So in order to make sure that we understand, we started working with an example, and that example was about the Wumpus world. Wumpus world is a 4 by 4 cave made up of 16 cells in that, and always the agent will start from cell 1 1, and some cell may contain randomly a Wumpus, a dangerous creature which can eat if anybody enters the room which it is occupying, or it may have almost infinitely deep pits. So if somebody puts a leg by mistake, will drain in and will never come out. So it's as good as dead. So there are some pits randomly selected. There is one randomly selected Wumpus, and randomly at some place there is gold, and the aim of the game is start from 1 1, and use your sensors to make proper decisions and try to reach the state, the cell where there is gold. So so the various actions we can perform are move further, take left turn, take right turn, or smell or feel the breeze, see the glitter. These are the activities we can do. Okay, then when you move further, you need to know what is status. So for that, you are given with a sense. Five senses are available, so you can feel the breeze, you can smell it, you can see the glitter, and so on. You are provided with an arrow, one single arrow, and if it is hit, so it may hit a Wumpus, or it may reach the end of the cave, hit the wall. So if it hits the Wumpus, you can hear uh, crying of the Wumpus, and if it hits the wall, you will hear the hitting sound, the arrow hitting the cave wall. You are given with only one arrow, but you can use as many times as possible, but only the first time will do some effect, but others will not. And because this is a game, so some uh, punishments what are there. So if you get a good amount, so you get plus one plus four points. And if you enter the chamber where there is one pus, or if they enter a chamber where there is a pit, you lose 1000 points. For every step taken, we lose 1 point, and for using an arrow, we lose 10 points. So, this way, when you come out, what is the maximum score you can have? So, with what score you can come out, or if you can't come out, why you didn't come out? That time, what happened with the score? All these are the game we need to look at. So, we try to look from our perspective as a human how we can do. So human, now you are able to see all sentences, or you are very aware that where ours is, where the pit is. So you can easily say there is compass here, there are pits here. So you should not go into this. The goal is to reach this state where we have gold. So how can you go? Yes, you can go this way, this way, this way, or you can go this way, and any other many possible ways are there to reach gold. So you can start here, go here, then come back, then go here, or you can start here, go here, go here, go here, come back, go here, and so on. And even after getting a gold, not necessary that you should come back with the same path. You can take any other path also. But only thing is, if you can't come out, there is one problem, or you may enter a Wumpus room, or you may enter a pit room. So the game is over. Okay, how to work out? So we thought we can apply some logic now. We started here, and 1 1, we found that at 1 1 there is no breeze. Since there is no breeze, this is when there is no pit here, and there is no pit here. And since we are not feeling any stench, no bad smell is coming, so we can very well say that there is no Wumpus here. So that means no Wumpus here, no pit here, so this is a safe place. No Wumpus here, no pit here, so this can be a safe place. So where do you go first? Device, uh, what do you say? Agent, he is facing to the right. So if you want to go to this cell, you can just make one move. But if you want to go to this cell, then he has to turn left and then make a move. So this will take two actions, whereas this will take single action. So we would prefer to go directly to 1 2. So we started from 1 1, and then we went into 1 2, and at 1 2 we found there is a breeze. So breeze is there whenever the neighboring cells have a pit. So if breeze is here, its neighbors are 1 1, 2 2, and 1 3. 1 1, we were just there. We had not found any pit. Therefore, no possibility of pit here. But I have not seen what is there at 2 2. Therefore, there can be a pit. And I have not seen 1 3. Therefore, there can be a pit. So, this is what I just keep in mind. There may be a pit here. There may be a pit here. I don't know what to do because both the neighbors are not guaranteeing me that I will be safe if I move. So I can't take any chance. So I will return back. So for returning back, I have to take a right turn, then another right turn, then move. So that means one right turn, second right turn, move. So that makes three moves here to come back. Move here, turn, check here, then feel the breeze. That's the next action. Then right turn, move. So one, feel the breeze. Two, first right turn three, second right turn four, then move five. So when you are back here, we have made already five moves. So 5 points we have lost. So we started with a zero. Now when you come back here, we are at -5. Then what you have to check? This is also safe. We know because there was no breeze, there was no stench. So we were sure that 1 2 is also safe. Therefore now we can try going to 1 2 1. So I have to take one right turn. So one right turn and then make a move. Right turn, make a move, then smell. No smell. So when there is no smell, one thing is sure, there was a confusion. Uh, when you smell it, yes, there is a smell. Smell confirms that there can be a Wumpus here and there can be a Wumpus here. Now, this cell we had already looked at from its neighbor. When we were here, we found that there was a breeze, and we never found there can be any uh, stench. So we didn't find any stench there, so which confirms that there can't be any Wumpus here. If Wumpus was there, there would have been a stench here. So because there is no stench, there is no Wumpus here. We had come here. Now we are feeling only stench. We are not feeling any breeze. So there is no breeze means there cannot be any pit here. So this looking from here, we said there is no Wumpus here. Looking from here, we said there cannot be any pit here. So the two enemies which are going to kill us, both of them are not there. Therefore, this also becomes safe now. Now we get into this. So once we get into this, find? What we find? We don't find a breeze because there is no pit around it. We don't find a stench because there is no buzz around it. And hence, we don't know. So we only see that all the four neighbors are safe to move. So from here, I can not smell anything, nor I can feel the breeze. So if you smell something, then either of these two, there should be a Wumpus. Or if you feel a breeze, then here or here, there should be a pit. So you are neither feeling a breeze nor feeling a stench. Therefore, you are sure that both these do not contain either pit or Wumpus. So now you are free to make your next journey. You can continue. So anyway, you have come here. Now you can just move one step ahead without turning. Then you can reach here, or you take a left turn, and then move here. And once you get into this, you can see a glitter. And the moment you see glitter, you get the gold, then make U turn, then right turn, then left turn, then up. So that's action we were looking at. Yeah, that's how the human version looks like. Done. So human version is simple to look at it. but it is not that easy if you try to look from the machine's perspective. So let's start working from machine's perspective. We are here, we are here, so that's where we say agent. So these are the things we're looking at: A for agent, B for breeze, G for glitter or gold, OK for safe, P for pit, S for stench, V for visited, W for Wumpus. So these are the uh, abbreviations we are going to use, symbols we are going to use for our future activity. Because I can't keep talking in sentences, now let me start talking in symbolic language. So we started here. So what we found here, did you find breeze? No. Did you find Wumpus? Sorry, stench? No. So no breeze, no stench. No breeze means there cannot be any pit here. There cannot be any pit here. No stench here. That means there cannot be any Wumpus here, and there cannot be any Wumpus here. So both pit and Wumpus are not there. Therefore, I can confidently say this cell is okay. Same way, I can confidently say this cell is okay. Now here the agent is um, facing right, therefore we can continue one step, go into the next one. Now the agent is here, so to remember that we have already visited this, so this will help us in get coming back, coming out of the uh, cave. We need the return journey. For return journey we just keep reminding ourselves which all places we have visited, so that you don't do similar exercise again, or otherwise, as we talked in terms of what is it, working with graphs, you should not keep doing same thing again and again, get yourself into a loop. So to avoid the loop, we say this is visited. That means don't try again smelling here, don't try again uh, feeling the breeze. Yeah, already done here. Okay, now you are here. Once you are here, you find breeze. So breeze here creates a doubt. This may be a cell with a pit. This may be a cell with a pit. Therefore, I am not sure which one is there. So we'll just return back. So from here, we return back, and then we go into this cell. Once we come into this cell, what we find is a stench. A stench here creates a doubt that there may be a Wumpus here. But if Wumpus was here, there would have been a stench here. But we didn't find any stench here. We found only breeze. That means Wumpus here, a stench here creates a doubt that Wumpus may be here or here. If Wumpus was here, then there would be stench here also. But we could not feel any stench. Therefore, being a Wumpus here is ruled out. And you are feeling that smell. We are feeling the smell, so which confirms that either of the two should be having a Wumpus. And just now we have disproved that Wumpus can be here. Therefore, Wumpus here is proved. So now just remember that cell 1-3 is dangerous. So in future, never try to get into cell 1-3, whatever way you get in. Done. So we have found that this is okay cell, because from here you didn't find breeze, therefore there cannot be pit here. From here you didn't find any stench, so there cannot be Wumpus here. Therefore both Wumpus and uh, pit are ruled out. So this has become a OK cell. Then after visiting this, we shifted to this cell. And when we shifted here, we found there is a stench here. Yes, definitely, because there is Wumpus in the neighbor. There we found a breeze. Definitely. So this stench did not make any surprise to us because we are very sure that there is Wumpus here. This breeze creates a doubt that there can be a pit here or there can be a pit here. Because Wumpus is here, there cannot be pit here because pit means anything goes in gets lost. So Wumpus is still there, which means that there is no pit here. Done. At the same time, you find glitter also. So success, we won the thing. Then you just recall how did you reach here? You have come from 2 2. So go back to 2 2. Then realize how did you come to 2 1? You come from 1 2. Uh, so how did you come to 2 2? You have come from 1 2. Then realize how do you come from 1 2? You came from 1 1. So this way you can get back. So that's the journey we need to take. Okay, familiar with this? Yes, minesweeper. What is it? It says it contains 10 mines hidden somewhere, and if you put your luck there, it just booms and gone. But yes, we have helpers to help us. So whenever you get into any cell, and if it doesn't have any uh, mine in the neighborhood, it doesn't have mine in that cell, you are safe. So it opens up and says how many mines are there in the neighborhood. So, like if you look at it here, or say this one, all the 8 neighbors do not have any mine, therefore, it is not showing anything. Talk of this, all the 8 neighbors do not have any mine. But if you look at this, it says one of the neighbors is having a mine. So who are the neighbors? This is the neighbor, this is the neighbor. If you talk of this, it says two of the neighbors are having mine. It can be here, it can be here, it can be here, it can be here. All these are the 4 neighbors. Out of these 4, 2 are having mine. So what can you do? One option, as we discussed earlier, make trial and error. So you can use something called backtracking. So go there. If you find, if you get into trouble, come back, try other way. Yeah, that is possible if you are searching for a route. You are trying to route for destination. You get into one path and reach your destination. Fine. If you don't, come back, try another way. Yeah, that's okay. But in this case, such is possible. So it's our then if I feel that this is safe and if I step into this, and what if this contains a mine? Dumb, I am gone. So when I am gone, what is meaning of backtracking? Who will do backtracking? I am playing the game and I am gone. Then who will do the backtracking? Nobody. The game is over. My life is over. The game is over. That's it. So there is no backtracking. So we can't rely on those algorithms which we worked earlier. Then we need to do something else. So that's what we call. We now start working more intelligently. What intelligently you mean? Okay, let me try this one. So how many neighbors it is having now? This is no more a neighbor. This is no more a neighbor. These were neighbors earlier, but no more they are already visited. So you don't have to. But what is this saying is one of the neighbors is containing a mine bomb. What is that one neighbor? It has to be this neighbor only. It has to be this neighbor only. No other chance. Okay, then who else? What about this? So this I am very much confident that this should be the neighbor. If you're talking of this, I can say this is the neighbor. Done. Because for this is the only neighbor. For this is the only neighbor. Same way for this is the only neighbor. So I am sure now, pretty sure that these two are surely going to have the bombs. Okay, next. Looking at this, it says two of its neighbors are having bomb. One, two, three, four neighbors are there. Out of this, one already found, three more. So which one I should think now? I am still not sure from this side. But yes, if you look at this, can I? It has got two neighbors. This is one neighbor, this is another neighbor. Which one can be? I am not sure. How about this? How many neighbors this is having? Yes, this is having only one neighbor. So if you look at this point, then it says that this has to be a cell with a bomb. And if you fix up this, then from here, one neighbor having a bomb, okay. One neighbor having a bomb, okay. Two neighbors having bomb, okay. So this is done. This is done. This is done. This is done. No, all of these are done. So these were attached to this. Therefore, now I am very much sure that these two will not have any minds. So I can click this. If I click this, they just open up and say that you are right. This doesn't contain any bomb. Then you continue. What next? I talk of this. I selected this. So it said this cannot be, this cannot, this is done, this is done. Now this is saying it has got only one neighbor, which is a bomb. This one neighbor already we have selected. So this will be okay for this. So if a bomb is here, then this cannot be one. This has to be two. This also cannot be one because this is these two because this is confirmly required because there is one here, one here. That means one here. That makes sense. But if this is also a bomb, then it cannot be one here, it has to be two. This also cannot be one, this has to be at least two. So this is one means this cannot be a bomb. And this is one, where is a bomb already. Therefore, this also cannot be a bomb. Okay, then what else? So that way we just have to apply our rules. We have to keep checking our knowledge and continue whatever we are doing everything parallelly and doing so much of activity. But can we make our machine to do this way? Definitely no, because machine cannot see everything in parallel. It has to do one thing at a time. It will see one problem at a time. It has to be solved like that. Therefore, we need some knowledge bank which we need to consider. So logic is what is going to help us in future now. So what is knowledge bases have to be created, and knowledge bases will consist of sentences. Sentences are the expressions according to some syntax of the language, specifies all the sentences that are well formed. What do you mean by well formed? Means it has some meaning and it should have proper meaning and it should also have perfect meaning. It should have semantics, some rules defining the meaning of the sentences, and semantics define the truth of each sentence with respect to each possible word. Yeah, we are now, because you can't be in a fuzzy world like we were. A machine cannot be in a fuzzy world. It has to be in a binary world. It is yes or no, zero or one. So we need to get in. Every sentence should be talking about something like a truth. So is it true or false? So that's what is required. Semantics define the truth of each sentence with respect to each possible world. And when we need to be precise, we use the term model in place of possible world. So this world and all that are human language words. But when it comes to machine, then uh, we need to give a specific name for that, and that name we give is a model. A model is one which defines the world we are talking of. So informally, we may think of a possible world as, for example, you're talking of an example again: X men and Y woman sitting at a table playing bridge. So what is it saying? X men are there, Y women are there, who are sitting at a table playing bridge. And there is a sentence: X plus Y is equal to 4 is true when there are 4 people in total. So the environment or the world is 4 men, X men and Y women are sitting at a table and they are playing bridge. And if the current world contains 4 people, then the total number of people sitting at the table should equal 4. Number of men is X, number of women is Y. So it says X plus 4, X plus Y is equal to 4. The world is 4 people are playing. Then X plus Y is equal to 4. The what is that? Syntax is X plus Y is equal to 4. Semantic is X is the number of men, Y is the number of women, and there is a table. Around the table, people are sitting and they are playing bridge. So strictly, we are saying that these X men and Y women are playing bridge. Other than this, some W men and Z women also may be there who are watching this game. They are also maybe there. So that means some W plus Z may be having something. Are we interested in? No, we are not interested in, because we are talking about the our problem is dealing with the people playing the game. So we are going to say that X plus Y is equal to 4 is the semantics we are looking at. And this is true as long as the total number of people playing is equal to 4. And if your world changes, if there are 6 people playing, then X plus Y is equal to 6. So that's what we were trying to talk here. Semantics define truth for each sentence with respect to each possible world. So for the possible world, there is a semantics and there is some syntax and all that. So what is semantic here? Semantic here is X plus Y is equal to 4. What is syntax? X is the number of men, Y is number of women sitting around the table playing the bridge. Okay, those are semantics. Syntax is total should be 4 is true. That is semantic. Small models are small assignments to the numbers to the variables X and Y. So X and Y in total should 4. So whichever values X and Y take, and after adding, if it becomes 4, can be the possible assignments of the model. Each assignment fixes the truth of any sentence of arithmetic whose variables are x and y. So if a sentence alpha is true in model M, we say that M satisfies alpha, or sometimes M is the model of alpha. Some definitions. Notation: M of alpha to mean that set of all models of alpha. So all models of alpha put together as a capital M that represents the model. Till we get into real examples, it's little confusing. Let's get confused. No problem. Some definitions. Logical entailment between sentences. There will be logical entailment between sentences. The idea that a sentence follows logically from another sentence. So one sentence can create another sentence which is connected through some logic. So when that is one sentence is creating another sentence logically, then we call it entailment, and it is represented by alpha and this symbol beta, which means that the sentence alpha entails the sentence beta. Formally, so alpha entails beta if and only if in every model in which alpha is true, beta is also true. So wherever alpha is true, so you just have any model. So for that model, if alpha is true, then for this model, beta is also true. Then you can say that alpha entails beta. So in the notation form, we can say M of alpha should be a subset of M of beta. So whatever is there, it should be there in this also. So this can have more, M of beta can have more, but whatever is there in this should be there in this also. Therefore, M of alpha is a subset of M of beta. More details when we are at examples. So let's go back to. So now let us entering this because agent starts his journey from one cell, and when he gets into one cell into the cave, neither breeze nor stench was. He found that one cell is safe. Then he gets into 2-1, and there he finds a breeze. These percepts, combined with the agent's knowledge of the rules of the Wumpus world, constitute the knowledge bank. So as you keep on saying, so you find breeze in 2-1, nothing in 1-1. You just keep assigning one by one, and whatever you understand, keep adding to the knowledge bank. So once you get into still 1-1, there is no breeze in cell 1-1. There is no breeze in cell 1-1 means no pit in 1-2 or 2-1. So no pit in 1-2 or 2-1 added to this. No stench in what you say 1-1, which says no Wumpus can be there in 1-2 or 2-1. Add to this. So in other terms, if you look at that, 1-2 says no pit, at the same time says no Wumpus, so that makes cell 1-2 safe. Same way, if you look at 2-1, so in the knowledge bank, somebody said 2-1 is safe from Wumpus, and somebody else said 2-1 is safe from pits. Therefore, you can say 2-1 is also safe. But you are already directed to the right side. It is easier to step into 1-2 cell instead of getting to do one cell because you need to make one turn. You want, you can do that turn. Then the agent is interested, among other things, in whether adjacent cells. So he has now found 1 1 is safe, 2 1 is safe, 1 2 is safe. He has entered into 2 1. So when he is there in 2 1, so he wants to verify what is the condition of 1 2, 2 2, and 3 1 pits. I think we are talking coordinates in a different way as they talk. Anyway, it only nomenclature problem. So let's define some what do you call sentences. So alpha 1 is a sentence which says that there is no pit in 1 2. Alpha 2 is another sentence which says that there is no pit in 2 2. Okay, what is saying? Alpha 1 has no pit in 1 2. So when you are what is that? We were safe at 1 1. We know that this is safe. There is breeze here. There is nothing here. Therefore, if you look at the breeze here, you find that there can be what is it? Pit here. There can be a pit here. From here, we have visited here. So 1 1 and 1 2 we have visited. After 1 1 1 2 visit, we are now saying that at 1 2 you found breeze. So these two should be a pit. So that's what we did. Then, so there are totally, so these two are now done. So who all are neighbor of these two? These three are the neighbors of these two. Of these three, so what all can be there? So you are talking about a breeze here. So if breeze is here, then what all are possible? There can be a pit here, there can be a pit here, then can be a pit here, then can be a pit here, then can be a pit here, there may not be a pit here, there can be a pit here, there may not be a pit here, there may be a pit here, there may be a pit here, there may not be, there may not be, there may be a pit here, there may not be here, there may not be here, may be here, may not 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 be here. I'm just looking from pit's point of view. Pit is there or pit is not there. So there are three options: this cell, this cell, this cell. So three options. That means if you write a binary combination of three options, then you are going to get eight. What are those eight? 0 0 0, then 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. These are the eight options possible if you are if you have seen these two cells. So if you have seen these two cells, now we are left with these three cells. So there are eight options open for these three cells. Out of eight options, only these options will satisfy your alpha condition. What is alpha 1 condition? Alpha 1 condition says there is no pit in 1 2. So there is no pit in 1 2. This is what is 1 2? This is 1 2. So this is there is no pit in 1 2. 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 So when you are sure that there is no pit in 1 2, and these two you already seen, now you are left with these two. So these two means you will have four options: 0 0, 0 1, 1 0, 1 1. These are the four options you have if you talk about alpha 1. What this straight line is saying, this the straight solid marked thing is saying that there are only three options here. What is it talking about? This is about our knowledge bank, which says that here We have not found any breeze nor any stench. Therefore, no Wumpus here, no Wumpus here. So there is no question of Wumpus in this. Then we have moved to this, and then we found that there is a breeze here. So because there is breeze, then we have to only worry about pit. And when we worry about pit, then a pit can be a neighborhood of where you found the breeze. It can be on this side, or it can be on this side, or it can be on the both the sides. But this one is not possible for knowing that there is nothing here, there is breeze here. If you have known this, then these are the three options open for you, not this option. But this option is only talking about there is no pit at 1 2. There is no pit at first column, second row. So that's what it is saying. Same way, if you look at there is no pit at 2 2. So 2 2, there is no pit, means out of these 8, you select only the things where this is blank, this is blank, this is blank, this is blank, this is blank. So these 4 are there, blank, 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 blank. So you select this. Okay, what are we now trying to say? Is something like set theory comes to head, I hope. Alpha 1 says this, that there are 4 possibilities. Knowledge says this, there are 3 options. Knowledge says this, these are the 3 options I know. And Alpha 2 says these are the 4 options possible. And what is it saying? If Alpha 2 is true, then knowledge bank is true. Yes, knowledge bank is always true. If Alpha 2 is true, then this is the only thing which satisfies both the conditions. Knowledge bank is also true, alpha 2 is also true, then this is the only condition which satisfies this. Done. Now these two will not satisfy. So if you find the alpha 2 sentence is to be true, then this is what you talk. That means if I know this as some uh, known thing, and if I get something for this, and if I want to talk only about this, then I can talk about some set theory operations. You can find some set theory operation for this. Yes, definitely. It is intersection. What about this? This was not having this, but alpha is having this. So this part you want to include. Then what do you do? Yes, you do union. You don't want. You want from alpha one. You want only this. Then you have to. What is that? Remove this from it. How do you remove something that whole alpha 1 is true, but only this part is not true? Something you have to say. Then what all things you require? Yes, again, set theory, you will come back. Okay. Two possible conclusions. Alpha 1, there is no pit in 1 2, there is no pit in 2 2. By inspection, we see the following. Alpha 1 is if KB is true, KB is true, it is there in alpha 1. So if KB is true, alpha 1 is also true. If for this, yes, KB is true. So this is in alpha 1, therefore alpha 1 is also true. If you consider this condition, the KB is true, alpha 1 is also true. But if you consider this, alpha 1 may be true, but KB is not true. So I don't mind whether it is there. Only thing what I mind is if KB is true, alpha 1 is also true. So this is what we call entailment, that KB entails alpha 1. Check out here. What is this? KB is a subset of alpha 1. Now check out here. If this is considered, then this is part of kb. That means for this kb is true, and for this alpha 2 is also true. For this kb is true, but alpha 2 is not true. Oh no. So for everything for which kb is true, alpha also should be true. Only then entailment comes in. So now I cannot say that kb will entail alpha 2. That means if I know kb, I can say I know alpha 1. But if I know kb, I cannot say I know alpha 2, because all which are there in kb are not there in alpha 2, whereas all which are there in kb are there in alpha 1. Why we are talking? Let us see. So by inspection, we say kb is entailment of alpha 1, but that is there is no pit in 1 2 and alpha 2. So there are some models in which kb is true but alpha 2 is false. So some models for which kb is true are not true for alpha 2. Therefore we say kb is not entailment of alpha 2. But we cannot say that what it is saying, that what are you trying to say, there is no pit in 2 2. So because of this, agent cannot conclude that there is no pit in 2 2. So this I cannot conclude. But because of this, I can conclude there is no pit in 1 2. But I cannot conclude, because this is not entailment, I cannot conclude that there is no pit in 2 2. But it doesn't mean that I can conclude that there is a pit in 2 2. I still don't know that there is pit or not. The only thing is, I am not sure that there is no pit there. Not having pit is unclear. So that doesn't mean that having pit is very much clear. So that's what we are talking of. So definition of entailment can be applied to derive conclusions, to carry out logical inferences called model checking. An inference algorithm that derives only entailed sentences is called sound or truth preserving. The property of completeness is also desirable. That is, an inference algorithm is complete if it can derive any sentence that is entailed. So, whatever you should be able to derive from the basic thing. And if KB is true in the real world, then any sentence alpha derived from KB by a sound inference procedure is also true in the real world. Yeah, we'll check out. So, coming to what a mathematical logic is the basis of all mathematical reasoning and all automated reasoning. Rules of logic specify the meaning of mathematical statements. Rules of logic give precise meaning to the mathematical statements and all blah blah. So many definitions you went on seeing. Now let's get into the reality. Propositional logic. Propositional statement is a declarative statement. So it is something to declare. It is declaring a fact, stating an argument, takes a value true or false, but not both. So there is no ambiguity, there is no confusion. It either has to say true or has to say false, or it cannot say both. Atomic sentences consist of a single proposition symbol. Complex sentences are constructed from simpler sentences using parentheses and logical connectives. What is a logical connective? We'll check it. A proposition is a basic building block of logic. It defined as a declarative sentence that is either true or false, but not both. The truth value of a proposition is true, denoted by T if the statement is true, and false, denoted by F if the statement is false. Example: sun rises in the east and sets in the west. It should be either true or false, cannot be both. 1 plus 1 is equal to 2. It should be true or false. B is a vowel, can be true or a false. There is declaration. Sun rises at east. If it's so, it is true. Yes, in this case, it is true. 1 plus 1 is 2. Is it so? Yes, it is. So it is true. B is the vowel. Is so? Definitely no. So this statement is false. So how many times you ask, whoever you ask, everybody says it is false. First sentence, talk to anybody, they say yes. Second sentence, talk to anybody, they say yes. Third one, talk to anybody, they say no. So yes or no, only two answers you get. If you get yes answer, every time you get yes only. If you get no answer, every time you get no answer only. Not that some say yes, some say no. No ambiguity, no confusion, nothing. So the sum of sentences do not have a truth value or may have more than one truth value are not proposition. What is time? It is a question. You are asking something. You are not declaring. So if you ask now, you tell one time. After 10 minutes, you ask the same. You get some other answer. So the answers keeps changing. Therefore, the answer cannot be yes or no. If somebody asks you what is time now, you say yes. So understand what will happen. Okay, just try once. Anybody ask you questions like this, you just say yes or no. Definitely, after 2 3 questions, he'll definitely ask you a question like, "Are you mad?" And you are going to say yes. Sure. Okay. We can't answer yes or no for every question. Go out and play. It's a command. You can't say yes or no. X plus 1 equal to 2. It can be both positive, yes or no. If x is equal to 1, the answer is true. If x is not 1, then answer is false. So it all depends on value of x. Therefore, you cannot confirm false, because it can take true or false any value depending on exactly x is. Therefore, it cannot be a propositional logic. So to represent propositions, propositional variables are used by conventions. These variables are represented by lowercase alphabets like p, q, r, s, and so on. The area of logic which deals with propositions is called propositional calculus or propositional logic. So this is what we want to fix up so that whatever we discuss as a human can be made understandable to machine. Atomic sentence consists of a single proposition symbol. Propositions constructed using one or more propositions are compound propositions, and the propositions are combined together using logical connectives or logical operators, and composition of all possible scenario in a tabular form shown is called a truth table. Oh, getting something? Yes, it is getting you towards DLD, definitely. So there are 5 connectives in common use: a not, which is negation, and which is a conjunction of conjuncts, or which is disjunction of disjuncts, implies, it is if then type of thing, and this one which is if and only if, which is a biconditional. A negation, conjunction, disjunction, implication, or biconditional. What are they? So a sentence can be an atomic sentence, can be a complex sentence. Atomic sentence may be true, may be false, or P, Q, R, S, and so on. Complex sentence is made up of a sentence followed by a sentence. Okay, or it may be a negation of a sentence, or it may be a sentence. It may be sentence in bracket, it may be sentence in bracket, it may be sentence, or it may be sentence and another sentence, or may sentence or another sentence. It may be sentence. What did you call this? Implies. This sentence implies this sentence, or this sentence implies this sentence implies this sentence. So bidirectional implication. So this is not, this is negation, and or implies bidirectional. What are they? Yes, your DLD will you recall that. So if P is a proposition, then it is shown by this symbol, not P. So this not P is used here because it is easier for us to type the things instead of putting a bar over it, which we used to do in DLD. So it is read as not P. If P sentence is true, not P sentence becomes false. If P sentence is false, not P sentence becomes true. So if the P says something like it is raining now, P says it is raining now. Yes, it is declaration. If it is really raining now, the answer is true. Then here, what is not P? Not P is saying it is not raining now. P is saying it is raining now. Not P is saying no, it is not raining now. So if it is raining, then this sentence is true. This sentence is false. If it is not raining, then sentence will become false, and this will become true. Conjunction, it is both are true, then only the conjunction is true. If any one of them is false or both of them is false, it is the all are false. So you get for both false, you get a false, false true, you get a false, true false, you get a false. When both are true, only then you get a true. So this is something like our electrical language. This is P. This is Q. Is P switch closed? Yes. Is Q switch closed? Yes. The circuit is complete. Then the bulb will glow. If P switch is closed, yes. Q switch is closed, yes. Then bulb will close because there is path for current to flow. Bulb will glow. If any one of the switch is open or both are open, there won't be a continuous path. Therefore, current will not flow. Bulb will not glow. This is analogous for your conjunction. In our logic language, we call it AND gate. Yes, this is AND gate we are talking of. Disjunction is either this or this are true, then the result is true. If this is true or this is true, you get a true. One of them is true, you get a true. It will be false only when both are false. So the electrical analogy would be, sorry. So two switches in parallel. If you close this, circuit is complete, it close. If you close this, circuit completes, it close. If you close both, then also circuit complete, it close. So only one option, when both switches are open, then no circuit is complete. Only false, you get false. One of you get true. That is operation or disjunction. Exclusive or, so both should be only one of them should be true, not both. So this is true. There, this is false. So it is true. This is false. This is true. Therefore, it is true. Both true, both false, not allowed. Both yes, both no, not allowed. One yes, one no, only are allowed. So this is XOR operation. Implication. It says if X is true, if P is true, then Q is true. So that means if P is true, Q is true, right? P is true, Q is true. Yes, it is true. P is true, Q is false. No, this is not talking. If P is true, Q should be true. This condition is failing. P is true, Q is true. Fine. P is true, Q is true. Fine. So this condition is holding. So I can say this is right. But in second line, you say if P is true, Q also should be true. But P is true, but Q is not true. Therefore, the condition fails. It's not true. I don't. If P is not true, then I can't talk about anything about outcome. If P is not true, I am not sure what should be Q. If it is saying if P is true, then Q should be true. If P is not true, what should I do? I don't know. I can't say P should be true, Q should be true, or Q should be false. It can be anything. So I am not sure whether if P is false, I am not sure Q should be true or Q should be false. So both conditions I should accept. Therefore, it looks like this. Confused? Okay. No example, no clarity. So P, it is raining. Q, I am wet. Or sorry. P, it is raining. Q, road is wet. No, I can say P implies Q because if it is raining, road will be wet. No, if it is not raining, can you guarantee that road should be dry? I can't. Because somebody might have spilled some water on the road, and because of that, road may be wet. So, because I can only say that if it is raining, road will be wet. But I can't guarantee that if it is not raining, road should be dry. That's what I'm saying. It is raining, road is wet. Okay, correct. It is raining, road is not wet. Then something is wrong. It is not raining and road is wet. Somebody might have spilled water on that. So I can accept it. If it is not raining and the road is dry, not a big problem. Okay, accept it. So these three accept it. This you cannot accept because if it is raining and road is not wet, so there is some problem. That means the logic is wrong here. So that's what we are trying to say. The other way is the conditional statement. It's also called conditional statement. P is called hypothesis, anecdote, premise, and Q is called a conclusion or consequence. Some basic bidirectional. If this is true, this has to be true. If this is false, this has to be false. One is true, one is false is not possible. Therefore, both true is accepted, both false is accepted. The other two is not accepted. That means it's exactly opposite of XOR. XOR was this is not accepted, this is not accepted, these two were accepted. This is opposite of that. So this is negation of XOR. That's a biconditional or double implication. P implies Q, Q implies P. Done. So that's the five things we need to look at. More details we'll see in our next session. We start working with more real-time examples and then continue how to convince our machine about our Wumpus problem using this propositional logic. Okay, till then, take care. Bye.